Well, hi, good morning. Thanks so much for joining me here in my shop. What I'm showing you is what I woke up to this morning, a view out the front of my house. This would be about 7 o'clock in the morning, and the sun has not risen yet. This is a pre-dawn view, looking out over Lake Couchiching out of my front window. You can see the lake here. This shiny area is Lake Couchiching down here. That's about 2 kilometers across. So the far shoreline you can see running along here is about 2 kilometers away. You can see there's a light from a house on the far side of it. Just to give you a little better perspective, here's my house. Oh, hey, there is my house. That's my house. And we were just looking out this window here across the lake. So we're looking out over the lake. So if you're familiar with this area at all, if you live in Ontario or something, you've probably heard of Casino-Rama. There's Casino-Rama across the lake from where I live. I live over here. This is Lake Couchiching here, a couple kilometers across and 8 long, I think, and then it's connected via a narrows right here, a famous narrows right here, to this big lake, Lake Simcoe. This is quite a large lake. There's a fairly large city located here of Barrie. And if we just go back further, you can see where I am in terms of the Great Lakes. If I go back even further, you can see where I am in terms of the world. But we don't need to go that far away. So the interesting thing about the connection between these two lakes, right through this little area here, this narrows right in this area, is there's a very ancient fish weir or fish fence in the water here, which was, according to the archaeologists and that, is about 5,000 years old. I can flip to that. Oops, that. So right in this area here is this 5,000-year-old fish catching system that was used by the people who lived in this area. You know, if you wanted to travel, if you were an indigenous person, you wanted to travel from this area, where there were a lot of people living in this area, over to this area, you either had to go around this lake, or worse yet, around this huge lake. So getting across at the Narrows was very, very valuable, and this made this a meeting point, or a place where sort of a centralized zone, if you like, a popular area, just as it would today. Even back then, hundreds of years ago, it was the case. So that's where I live. So yesterday I was pretty excited at the success of finding a bad capacitor in the radio and changing it out and having a great improvement in the operation of the radio. There's no question that was the bad guy here. But when I tested it, I right away thought, oh my gosh, there's a couple more of these very same type of capacitors. There's one that's the same size right here. There's 1, 2, 3 of these older mica type capacitors in here. I'm thinking, and there still is, I believe, a problem, which we're going to try to listen to in a moment when I turn the radio on. Then I think I'm going to proceed and change out some of these, even though I tend to never change a mica capacitor. That doesn't seem to be the case with this radio. I guess like everything, there's different qualities of mica capacitors. That these ones maybe are just, not up to living for 100 years. This isn't 100 years old, not yet. But so given that one of them tested so poorly, I'm pretty tempted to do the rest, along with the fact that there's still a problem. Now let's get the problem happening here so we can study it a little bit. The problem is when you tune in a station, along with it comes a second tone. this second tone is what I'm curious about. So we're going to explore that a little bit. I do have my signal generator running, but it's not connected to the radio in any way. Here we come. So if you listen carefully there, as the radio warmed up, you could hear a tone go doo, very quietly. That's the tone I'm after. Now, a lot of other tones coming out of here from interference, but the one I'm after will go up and down as I tune the radio a bit. There's almost nothing there. I'm getting ready to chase another ghost. Okay, so this is exhibiting the sound a little bit. There's a station there. This would be 840. Oh my gosh, this radio's working really well. That's not 840. That's so when I'm working on these radios, as they start coming to life like this, I begin hunting for stations that are more difficult to catch than the one I usually use. 590 is my usual first station. It's pretty strong in here. The rest are quite a bit weaker. This is one of them, and it's coming in really good. So this radio is really performing well. And I think it may, I gotta find out what the frequency is. So it's pointing at about 820, 830 here. 800, 900 million. So the directional antenna that all these radios have, it comes with a direction where it'll receive better, and then a direction where it will receive really poorly. That really poorly direction, the null direction, is very important with these antennas because you can use it to knock out a noise source or a interfering other station as long as they're coming in a different direction. So let's just demonstrate that. So, of course, the truth, I'm swinging the null, I'm swinging the strong direction too. Yeah, bad demonstration. Well, there, now the null is aimed at the station. Very good. Anything else we can pick up with this? 1010 would be the next possible station. Let's go back to 840. That sound. So sometimes you can have the station you're after and the station you're trying to get, and the station you're after, and there may be a noise signal sitting right next to it, maybe within 5 kilohertz. And as you tune in this station, you can't help but tune in the noise at the same time. The combination of carriers going into the mixer, well, they'll mix, and you'll end up with the difference frequency. It's a tone. So you can hear it. So you'd hear 1,000 hertz tone, but it wouldn't go up and down. It would stay fixed. Every time you tuned in, there'd be that annoying tone. Some radios have a notch filter, and you can notch out that tone frequency, that audio frequency, and get rid of it. But it's not going to go up and down as you tune through it. The up and down thing is a little different. In some radios, you can get the IF so tuned up that it begins to oscillate on its own. The oscillation doesn't produce a sound out of the speaker, but it would produce an AVC voltage, probably dramatically, and it's going to quiet the radio down. And as you tune through a station, and I'm not going to get this right, that's why I want to fool around, because I don't fully understand this. I have my machinations going on in my head, but I don't know how true they really are. So let's get back to what's in the radio here. So there's 3 capacitors we might call suspicious, because they may be similar in operating quality to this guy. They may be in positions where a little bit of a leak doesn't matter all that much. Like if we take a look at this one to start off with. So it's going between the grid here. No, it's going between the plate, the triode plate, and the negative terminal. So almost certainly the job of this guy is to get rid of RF that may be coming out of this tube, because at this point we only want audio, and any RF that's made it into this tube could get amplified, and so this is to kill it away. This guy's doing the same thing, only he's ahead of the game. He's trying to, I shouldn't really say it that way. It's providing a signal ground to the bottom of this coil. At the same time, it's robbing away any RF that might be sitting here because it's provided the signal ground. So all that could be left is audio stuff in here. So either one of these are weak, and a little bit of RF is going to get on to where you don't want it to go. Some of the RF, if it's still present here, if this capacitor is not doing its job, it'll come back this way and work its way back into the early stages of the radio. Now that might cause this tone effect that's bothering me. So maybe what I'm going to do, and so that's these two. Now this last one here is basically helping the local oscillator in its operation, and it looks like it's just blocking away. Is it blocking anything away? Is it blocking away some DC? Well, I don't know why. I don't know why it's there exactly. You could have a continuous wire here, but obviously that doesn't work well. Exactly why this capacitor is here, I don't know. But I'm going to guess that's going up to, well, it's very hard to tell what's going on in this tube. So this is the grid. Pin 1 is the grid. Pin 2 is the cathode. So I have the cathode current flowing in here, and then that's transformed over here, and then the signal developed in this coil is capacitor supplied to the grid. So if this guy is not working well, it wouldn't supply as much. Kind of what this one was doing. This one wasn't really supplying as much signal as it could. Plus it was, yeah. You know what? Let's go for this one next. I'll find this guy. He's the same size, 47, as this one. And we'll just get it out of there and then tune the radio around, see if some of those tones have disappeared or not. I think it's the other ones that are responsible for the tone, but let's find out. Okay, a little closer here. Not hard to spot the 3 capacitors. 1, 2, and 3. This one is the one that's associated with the oscillator coil. Doing anything around here could kind of upset the arrangement. Certainly force an alignment, or make an alignment worthwhile doing after changing it. But I haven't aligned this radio yet, so I'm going to take this one out and give him a test, and then I'm going to replace it, and we will see. But I don't usually literally ignore these kinds of capacitors, but let's go a little further. Okay, I'm leaving some tail here. Put this guy right into the tester here. Okay. Why is this closed? I haven't got that all the way over. Okay. So 50 volts should be nothing for this capacitor. It should pop open and look just like that almost instantly. Now it's a dud. It's leaky like a sieve. Okay, same as the other one. Not too surprising. If you take one out and test it and it's bad, they're probably all in the same condition. I mean, they've been traveling together. So, okay, so I'm going to put a proper 47 and we'll 47 picofarad capacitor, and we'll test that again. Okay, that guy's in there now. There he is, right there. Soldered in. So yesterday when I was working in here, if you watched the video, you probably did. You know I replaced a resistor and did it wrong. And afterwards I was thinking about that. I like to think about my mistakes. To me, it's all part and parcel of doing this work. For me, anyway. Maybe you're the sort that just doesn't make mistakes, but I do. I like to understand, well, how did I make that mistake? And the fact is, it's more your fault than it is mine, because you were distracting me by listening to me talk while I was doing the work. Now, one of the things that's true, and it's happening right now, is while I'm talking, I'm distracted. I'm using some portion of my brain power to generate the words that are coming out of my mouth. This is a recognized thing. If you're a pilot and you're doing your landing approach, there comes a point where in the cockpit, the only thing people are allowed to talk about, the pilots are allowed to talk about, is the airplane flight itself, the operation of the airplane. They can talk about nothing else. They call that a sterile cockpit. I'm not exactly sure why they chose the word sterile, but that's what they call it. So for me, when I'm doing the work now, I tend to not put it on video, so I turn the video off, and as long as I sit here alone, I'm alone all the time actually, as long as I keep my mouth shut and I can concentrate on what I'm doing, I'm far less likely to make a mistake. So I'm yapping away, probably going to make a mistake right now. So let's turn this radio on. Watching the dim bulbs. Doing the right thing. Very good. A little volume. A little more voltage. Too bad we use the word voltage. Voltage, it doesn't mean anything. If we use the right term, it would be, ooh, lots of volume, it would be pressure. We would say pressure instead of voltage all the time. So that's that same French station. No, still swooshing. Now the swoosh can be another effect. There can be a noise signal in there. It can be modulated. The modulation can sound like this. Okay. And as you tune through it, you initially, because of the shape of the response curve, you're selecting the highs before you get it tuned right in to the middle, where you're then selecting the entire signal, hopefully. And then as you move out, you select the highs again, so you get a sound. Like that. Hey, another good clear station. Neil Young. Neil Young, great Canadian artist. From he lived up near here for a while, I think, or I may be confused. The greatest piano player ever, a guy named Gould, lived right up here where I live now. Not that that's helping me play the piano. I can't play the piano at all. Let's go after the other two capacitors now. So, if this was interfering with the operation of the radio, I think the main thing it would do is weaken the oscillator signal that's getting on the grid here, similar to what this one was doing, because it was bad. It was weakening the antenna signal getting onto the grid. So, perhaps the radio is a little stronger now. Helpless, helpless. We'll go after these two. Let's do them one at a time, because they're doing different jobs. We'll do this one first because I think it's the least likely to impact on the radio. It's a these are both 270 picofarads. They're like 5 times the size of these. You didn't look at. Yeah, so we'll do this one first, and it's between pin 7 and pin 2. Okay, pin 7 and pin 2. Did you notice me jerk my hand just then? Does this happen to you? Just as I was moving my hand over there, I had a little nerve thing in the finger here that just, a little momentary ding, felt like a needle prick or something like that. But of course, I react like it's an electrocution all the time. Does that happen to you? Are you that hypersensitive now? Okay, so here's the two of them. Between pin, I think it's going to be this guy. Again, pin 2 and 7. That's pin 7. Yeah, 2 and 7. And this guy is hooked up to one of the terminals on the transformer. That'd be this one for sure. Okay, so this guy we're doing first because I think it's least likely to be implicated. Now maybe we'll cut that out and find out it's just fine. Let's find out here. Sometimes the simpler the radio, the easier it is to learn stuff. I'm going to cut it right at the terminal. Okay, I put a clip lead there just so I can't forget where it's come from. Or let's just say it's going to make it less likely. I can still manage to forget. Likewise with this one. Because I'm cutting them right at the terminal. Cutting the leads right at the terminal. Arrow Vox, and what did I do with the other capacitor here? Made in Canada. Arrow Vox. Made in Canada. Okay. Okay, 50 volts. Now maybe you can read it says 25 volts, but it's actually 50 if you were to measure it. Look at that. There's nothing wrong with this capacitor. Okay, so I'm not forced to change that one. But I think based on that, I won't bother with the other one. This one here. The operation of the radio is very good. I think the story I'm telling about the tones and that is a bit of a ghost story. And it's pretty minor stuff. But we'll have to replace this because I don't think I can possibly tack it back in there. There's just no leads. Okay, I will do that. Okay, that's very odd. Looked over at my software I use for making these videos, and the record button has changed. It has a different shape from the last time I looked at it. It's pretty odd. Here we go. And just in thinking about it, I think I probably will change the last capacitor, because everybody's going to be saying, well, why didn't you change the last capacitor? And you know, in terms of doing these experiments, making these observations, I should. Even though I'll bet you there's nothing wrong with it. Lots of volume. There's an example of nulling out the interference. Very narrow range. Excellent. It's working better and better. Same thing again. You'd never find it at where'd the French station go? There it is. Still got the swooshy sound. This is now that's one of the best performing radios I've had in my shop now. It's really working well. Excellent. Well, let's go. One more capacitor. One more to go. Why not? Would we call that the trifecta? Would that what that would be called? Now, it's this one. Okay, get that clip lead ready. Trim it again right at the terminal. Same brand. Okay, let's give it a go. I'd be really floored now if this tests differently than the previous one. So you gotta wonder, well, what's the difference between the 47s and the 270s here? Is it just a bad day in the factory when they made those other ones? Okay, here we go. Look at that. Hey, give me back that last one. I think it's this one here. Oh, I'm mixing them all up. Yes, I've mixed them up. Test them all again. mix them all up. Okay, this one's been tested. And they all look the same. So eye is staying closed. There should be 4 of these on my bench. And number 4 appears to be missing. Hey, what's going on there? Did you see what happened here? It's very different than the other response. And if I could just spot the 4th one, it should be just laying right around here. I don't know where it is. Where'd it go? I don't know. Well, could be that test that where I said, "Oh, look at it's good." Maybe the leads weren't connected quite right, or maybe that's the 4th capacitor that's floating around my operation here. Just by looking at them? No. Okay, so they're marked. So these 2 are the same and this one is different. Okay, that's how it goes in my shop. Oh my gosh, I didn't put the clip on. I did not put the clip on, but I can see it's right here. This is the spot. Okay, I'm going to stick another 270 in there. Okay, we're ready for another test. So I think a big lesson here for me is I've been too trusting of these kind of capacitors. I've probably let quite a few bad guys go by in the past when I shouldn't have. Just out of a sense of faith. Faith. Another word for faith is suspended judgment. Let us not have much faith in anything. Okay, what's the difference?
Decreasing capacity at essential retail.
Still got that tone in it going, the heterodyne sound. Didn't seem to change much, but the performance, if anything, has only gotten better as I've changed out those last few capacitors. So what's left on this radio is to do a proper alignment, and then I just can't imagine that there's more to do inside. Well, things are going so well, I've decided to carry on and see if I could mess up the radio by doing the alignment. So there we are, 455. I've got the feed into the grid of the 12 VA6, so we're just going to do this IF transformer, which is number 2, which is the lower one in the radio. Okay, and my expectation is that in fact this is well tuned. I installed the capacitor right above the adjustment here. Okay, now I want to watch this meter. It's full volume. Okay, here we go. Down, down. Then something's jumping around. What's happening there? Come on. Okay, that's not even the, that's the bottom of a tube socket. Duh. There we go. Okay, watching the meter now. Just a little odd. Odd in that there was like a bump in that control. I had to move the camera out of my way here. Get in the top one. There we are. Okay. Making no difference. Oh, I got the wrong one here. Yes, I do have the wrong one. Come on. There we go. Okay, this time. Just a wee bit up from where it was. There. Now, pull this off. Whoa. Oh, that was a little more than I expected. Okay, now we're down to the next one. Next one is pin 7 of the 12BE6. 12BE6 is here. Pin 7. It's very easy to get to. Pin 7. Okay. Gives you an idea how weak the signal generator signal is. That doesn't seem right. That does not seem right. I would expect it to be a lot louder. Pin number 7. That's definitely pin number 7. Okay, we'll give this a little more oomph. Oh, you know what? I mistuned the transformer. Right. Okay, starting here. Let's go at the top, the one that I tuned out. Okay, here we go. Doesn't make much difference. And the bottom. Seemed a little odd to me that I had to put a higher level of signal in to get that done. But okay, volume down this time. Let's take this off here. Okay. It didn't make much difference on the IF. That's like the third time I've taken a run at it. So what we want to do next on the table here is connect to the antenna. This suggests a 400 ohm dummy antenna through series dummy. They're quite specific here. Up to 1460 and oscillator trimmer. 1460. I actually have a mark right on the dial here. 1460. There's another mark down here, which we'll probably get to next. So we'll go right on there. That's got to be 1460. Let's get the parallax right on the money. Okay. Now, dial this up to 1460. 1460. I don't have it connected to anything. So rather than use a dummy antenna, I'm going to do this by induction into the antenna, which I think is a better way to do it. Just drop this coil right here. Get a little sing-songy at times. Hey, where are you? Oh, maybe how about some volume here? So it's around 1500, in fact. Okay, so we'll make this could really help this radio. So we want to adjust. Well, look at that. I have a screwdriver. Yeah, look at that. So the capacitor's back there with 2 trimmers. How are you going to get to it? They put a hole here for your screwdriver to go through. Okay, I'm not going to use that. I'm going to use... Let's try this. This is fairly stiff. Okay, so we're still tuned to the dot on 1460. I've got to move the camera like this. Okay, we'll go in on the oscillator. Some wire interfering here. Okay, we're in there. Now, 1460, so we'll go in that direction. Figure out which way to turn this. Tightening it. Well, it's pretty tight already. Okay, can we get to 1460? Yeah. Okay, now that's correct. Now leaving it at 1460, we do the antenna trimmer. I should take all of 12 microvolts on the antenna. I don't have it hooked up directly though. So actually got a very strong signal sent over there right now. Meter's gone wonky here again. Okay, never mind that. Here we go. Tune up the antenna. Let's hope it really comes up. Stronger screwdriver for this. Big long metal shaft. Not too dramatic. A little bit of ABC action there that's making it tricky. Nothing too dramatic there. Okay, let's see what we got. Pretty consistent. Here we come. Where'd you go? Oh, there it is. Good. $590. $640. $740. Isn't that interesting? There we are. I'm looking for it in the wrong spot. 840. I'm going to try that antenna trimmer.
Against the Pacers and the Wizards on New Year's Eve and New Year's Day. Chicago getting set for their next game tonight when they host the Orlando.
There we are. I think it's working quite well now. Wish all that swooshy noise would go away, but I think that's just the level of interference signals is so high in here, and they're much higher than the broadcast signals, that you can't get very often an AM station that's not got something right up beside it causing that interference. So I think it's thumbs up on this radio. That was pretty interesting. I enjoyed that, actually. Learned a fair bit. Got my rear end kicked with these capacitors here. Good. Okay, so I managed to find a light bulb I can replace the original one with. It's a much longer light bulb, but it's good for a test. Anyway, let's stick on the power, and for the full effect, go semi-darkness. Here we go. Wow, that's a little bright. A little bright in the camera there. Still bright in the camera. It's definitely bright. I think it's probably too bright a light for this. Now, how am I going to get this on camera? I got to turn on more light. Still hard to see, isn't it?
Que vouliez-vous, c'est comme ça. Puis on se retrouve pour l'insolite, oui, cette chronique de l'insolite en dernière de l'émission. Alors, à tout de suite. Merci.
Merci.
Le petit pèlerin, dictionnaire du Caxton vernaculaire.
Secret de Polichinelle. Secret de Polichinelle.
Secret de Polichinelle. Locution nominale. Définition. Chose intime que l'on confie in petto à son coiffeur et qui sera rapidement connue par tout le monde.
Polichinelle, c'est un personnage méconnu de la commedia dell'arte.
Well, I have no idea what they're saying, unfortunately, even though I took years of French in school, public school, and a couple years in high school, and I got absolutely nothing out of it. What a shame. I wish to heck I could speak French, but I can't, so that's unfortunate. Being Canadian, it would be great. Okay, so that's the end of that. That is definitely the end of that. Thanks a lot for watching the series, and see you on the next when I start the next series. Bye.